Cheers, Warsaw, and thank you, Awwwesomes, for inviting me. So this evening we'll be taking a deep dive into the code which is used to build a progressive web app. There's a lot of code to cover and a lot of details which I would like to go through. So instead of setting it up as a live coding session, we'll take a look at existing code. We'll stage it out over 3 stages basically. So from a server-side application to a client-side application, and finally a fully fledged progressive web app. And we could go through this code. All code will be available on GitHub, and I'll be able to, I think, can we send the links? Yeah, so we'll send the links afterwards. And if anyone has any questions, just feel free to interrupt me at any point. So first, a bit about myself. I'm a co-founder at Incredible Web. We are a software development company based in Malta and specialize in web and mobile applications, ranging from simple e-commerce to more complex enterprise-grade applications. I fell in love with progressive web apps when I first started working on them about 2 years ago, mostly because I believe they play a critical role in bringing the next 1 billion users online, especially in areas of low connectivity such as Africa and parts of Asia. Since then, I have written for Smashing Magazine on the topic, and I'm currently in the process of writing a book for Pact Publishing. So let's start with a bang. Native apps are doomed, or so Eric Elliott said almost 1 year ago. This is often the hot topic when discussing progressive web apps. Will they replace mobile applications, and if so, when? But until recently, there was one major hurdle with web versus mobile, and that is Apple and WebKit's limited support for PWA technology. This was seemingly the case because of the large revenues which are generated from the App Store and what would happen once we are able to build native-like applications using the browser. However, earlier this month we had some great news. So this came out from WebKit, that they have changed service workers and they are currently in development. Service workers will cover them a bit later on, but they are the cornerstone of most PWA technology, including offline, caching, and even push notifications. So while this is a huge step forward, it is still not clear how Apple will be supporting PWA technology, but it is definitely great news for this month. But what are PWAs? So I describe a PWA as a mobile-friendly application that may be progressively enhanced to include native-like capabilities through the modern browser. So we're using our web browser to create something that looks and feels like a native application. But PWAs are not a new idea. So according to Walter Isaacson's biography of Steve Jobs wanted that iPhone apps would be written using web technologies. However, developers, once they came to release these or come to develop these apps, they weren't very happy with this. And after a few months, it was announced that Apple would be working on an SDK, which later became known as the App Store. And 1 year later, after the iPhone, we have the App Store. Since then, obviously, it has become a tremendous success. But why build a PWA? So one of the bigger advantages for building a progressive web app is that it uses web technologies. So according to Stack Overflow survey in 2017, 72% classify themselves as web developers compared to 23% who classify themselves as mobile developers. And this is obviously a huge impact on the ecosystem. So the number of plugins which are available and the number of packages and the number of support. So by building using web technologies, you're gaining access to much better tools and a much better and bigger and more mature ecosystem. Also, native apps, according to statistics, lose approximately 20% of its potential users at every additional step. So when you're downloading a native app, first you need to find out about it, then you need to go to the App Store, then you need to install it, then first download it, sorry, then install it, and then open it, and then you can use it. With web, we eliminate all this friction, so once you are on the web, on the page, you are ready to use it. Also, trying to encourage users to go towards the native application, which obviously has its advantages, but trying to encourage users in such a invasive way, as we see here from LinkedIn, is a poor user experience. So I want to use LinkedIn on my mobile, but first I have to tell LinkedIn that no, I do not want to use the app, and very often this could also keep showing up. So this is obviously damaging to the user experience. Since then, I think LinkedIn have changed it, but I am not sure. So a progressive web app should follow the principle of progressive enhancement. It should be built in a structured way where HTML and content are always available, irrespective of the user's device. And this is also should apply for non-progressive apps, for normal web development. Very often in today's modern SPAs, you see that the website would not work if there wouldn't be JavaScript enabled, for example, or it would be impossible to use. So progressive enhancement is the principle where we build in a structured approach. So first you have the HTML and the content always available. Then we add CSS, by nature it is unobtrusive. And finally we add JavaScript in an unobtrusive way. So we're building it upon an existing layer rather than changing directly, as you see, for example, in this example. So progressive web apps, what they aim to do, they aim to take the features which work very well on native applications. So, for example, the biggest win for native applications are push notifications, because push notifications have a huge retention. In the case of e-commerce, there's an increase of 278% if users have push enabled on their native app. So what we try to do with PWA is we try to take these key features from native apps and take them onto the web. So if we look at the properties of a PWA, according to Google, it has to be progressive, which we have already discussed, responsive, so it has to work both on mobile and on desktop, connectivity independent, so it should be able to work offline and in areas of low connectivity, app-like, so it must look and feel like an app, fresh, if there's new content, it has to download the latest content rather than keep what it has in cache. Safe, it has to be served over HTTPS only. Installable, so it's a new feature which we have with PWAs, is that you're able to install it to the home screen on your device. So if the browser thinks, and there's some criteria like you have to return to the app twice within 5 minutes, for example. But if the browser thinks that your web app is good enough, then you have the option to install it to the home screen. Discoverable, so one of the advantages of the web is that everything is indexed on Google, and we're able to search for progressive web apps. It is probably a bit easier than to search for native applications. In fact, very often the user journey to a native application, they find the website, and then from the website there's a link to the native application. Re-engageable, which we covered through push notifications, and linkable. So any state inside the progressive web app should be linkable in the form of a unique URL, which is a feature which we have on the web already. So one of the models for designing progressive web apps is the app shell model. And the app shell model states that the app shell, so we've got the top navigation bar and the navigation bar at the side, should always be visible for immediately, and then we add the content afterwards. And the reason is for perceived performance. It will seem like it is loading faster, and also for offline support, so you're going to have the app shell visible, and then if there's no data available because there's no connection, in the middle we'll write no connection or something like that. However, the app shell model is a bit of a hot potato because the app shell model is not progressive in itself. So when we're talking about progressive enhancement, this method means that the data will not be available. It is going to be loaded afterwards through JavaScript. So the app shell model, while it is one of the techniques, it is not necessarily the only one or the best one. So service workers, which I mentioned, are the key for progressive web apps and what enables these native-like features. They're a script which run in the browser, but outside of the DOM, so outside of your website, and they run at a lower level. They require HTTPS because since they're running at a lower level, there has to be a bit of an elevated level of trust. So you do not risk any sort of, for example, man-in-the-middle attacks where someone is sitting in between your service worker and the API, or from where you're retrieving the data, and they're able to send malicious content. The flow of a service worker, it will be installed, it will be activated, and it will run idly, so it will always be running on your web app. And then, if there's like a push notification or a message or a fetch, it will run by itself in the background, and it will communicate to your web application through a message. The next part from the PWA is the web app manifest, which is basically a JSON. It describes your web app. It's very simple. It includes details about the application itself, some icons which will load, and the option to load in full screen, for example, and to load, for example, to enforce loading in landscape, and some additional UI features to make it more app-like. So for this session, what I have set up a GitHub repository. You can download the code from there, and we'll be going through it to take a look at the code which we need to build a progressive web app. So the code, like I mentioned, is available on this URL. The slides will be made available, I guess, so you can take it from there. Feel free to try it yourselves, of course. And through this session, we're going to go through, there are 3 branches. So the master, which is where we're going to start. Then we're going to add the client-side improvements. So this is in line with the progressive enhancement. And finally, we're going to turn it into a progressive web app. So this is are you able to see? This is the terminal. There's not going to be much to see. But does the code show at the back? Yeah? Yeah? Okay, great. So, first thing to do, obviously we'll have to run npm install. We download the code, run npm install. It will download any packages which we have as requirements. I have already done it over here, so it's already up to date. And finally, what you need to do, npm run watch. And npm run watch is going to run Webpack. In this case, we're using Webpack as our build tool and also our module loader. And then we've got on the other side either npm start, or we could run, let's run npm start. And we've got our website running on localhost 4000. So we've loaded in Chrome. So we've got our app running. Okay, now I'll take a look at we'll go through the code briefly. So we're using Express as our backend, our server-side backend, so everything is built in Node.js. And the reason for this choice is because we want isomorphic application. So the server side and the client side share as much code as possible. In this case, it's all done in JavaScript, so that makes it much easier. So if anyone is familiar with Express, we set up just over here, I'll skim through the details. But we're setting up an Express server, enabling some compression and some other middleware which is related to Express. We're going to be using handlebars for our templates, so this chunk just sets it up here. Some more Express stuff, an Express session. This part is not relevant for the session. Then we set up something called a path config, which is going to be used for our server-side content. We've got a learn URL which accepts posts. Everything else accepts get. Okay. And when we get, what we do, we check the URL, we retrieve it from the path config. I'm skipping through this because it is just details mostly. And some extra logic if we are on the learn page over here. So this is basically some session management. Then, if we take a look at server and we take a look at the path config, over here is where we are setting up our server-side logic and our server-side routes. Now, each page will have a default path config, which includes inline styles, remote styles, and remote scripts. The reason for this is because when we run our page in handlebars, what we're doing, we are going to load any inline styles in the head of the page. And the reason for this is to not have a flash of unstyled content. So sometimes when you go to a website, first you see it without any fonts and without any CSS, and then all the CSS comes in and it updates it afterwards. And we're adding the inline styles above so that we eliminate this, because again, on a native app, you're not going to have these flashes of unstyled content. Some partials, and what is interesting is the async CSS. So async CSS is another partial in handlebars. And this one, what it is doing, it is loading the CSS through JavaScript. So we're doing a JavaScript call to load the CSS. And the reason to do this is to enable asynchronous loading of the CSS. So we want that CSS is blocking. So you want to load the CSS, which is not going to be visible above the fold. You want to load it afterwards, because you don't want to block the whole page until all the CSS is loaded, especially if you've got a large site. So what we do, we'll put these separately and load them asynchronously. And this is done here. However, in line with our progressive enhancement, we also have a no script. So just in case the user does not have any JavaScript enabled, we're still going to load the CSS correctly. And finally, we've got the remote scripts. So remote scripts are just going to be loaded normal JavaScript files, and they're going to be loaded asynchronously, and they're going to be placed as the last item in the body tag. Okay. So what we have set up over here, we set up a mock service, which is going to be simulating a request to an API from where we're going to be retrieving the data. I won't go through this, but this is just a normal request which is being mocked. And finally, we've got our source over here in which we put our normal JavaScript, images, and style sheets. In this case, we're using Sass. With all this set up, we have this page. And this page would load without any JavaScript enabled. So we have the idea behind this was to make it as similar as possible to a native application. You've got the home, get started. So this is going to be an application through which we'll be learning Polish. You choose the request, and what is important over here to note is that the URL is always updated, because this is again one of the principles of a well-developed PWA. And what's happening when I'm selecting one of these, I am sending a request to the server, getting a response back, and updating the UI afterwards. So if there's no JavaScript enabled, it will continue working properly. We'll go to our next level. This is just a demo of the app. And we finish, and we learned Polish. We've got some settings. So for now, we have a server-side application which looks as much as possible as a mobile app. The next step would be to enhance this through JavaScript. Now, to enhance this through JavaScript, I will download the latest. So let's stop this. Git checkout. Client-side improvements. So what I'm doing here, I'm downloading our latest branch, which includes some of the JavaScript. And the JavaScript is built in an unobtrusive way. So it adds above what there is without stopping it. And if we run node npm start, sorry, it runs our server. And if we have this now, we should see we have to run webpack, npm run watch. So if we have our page now, we should have it working without any requests back to the server. So whenever we're navigating from one page to the other, we have enhanced it so that it doesn't do any requests. And this is a step towards reaching where we want to be, our PWA, because once again, a mobile app does not stay flashing whilst it is loading pages. The UI remained identical, except it is now done all done through JavaScript. And this remains the same. Yeah. Okay. So, if we take a look at what we have added, so as I mentioned, this is going to be framework agnostic. So ideally, you would be using something a bit better than what we have here. So a bit more complex and a bit more featureful, such as React, Angular, or what other JavaScript frameworks are available. And what we have set up our own router, and our router is taking care of rendering the pages. So whenever there's going to be a click on the navigation, so whenever we're going to click here on one of these items, instead of going back to the server and bringing the content, what we're doing, we're going to call our router, which is this over here, and we're going to call render. And render, what it will do, it will contact our API, our mock API, which we looked at earlier, and it will retrieve the content and it will replace it inside the HTML. So this section, all it does, it gets the content for a specific URL, gets any data, if there's any data available, so for example for the learn page, and it just updates in the most crude way the HTML. So we're putting in our HTML and we're replacing. And the advantage of this over what we had before is that we're consuming less data. So every request, we're just getting what is changing. So it has become much smaller. We can see performance improvements and even UI improvements. The navigation over here. So if we take a look at the HTML of the navigation, we have not changed anything. So these are still fully functional hyperlinks. So if I disable JavaScript, everything will remain working as it was. The difference is that through the navigation over here, we have added a click event listener, which is going to catch any clicks, block the page from going to another page and retrieving the data, and instead call our router to retrieve the content. And this was one step further towards reaching our goal of a progressive web app. Now the next step, and most interesting, would be the features which are related to service workers and push notification. So if I will git checkout progressive web app, it's the next step in our process. npm run watch. Okay, and here we will npm start. So we've got the same thing running again. If we load this, okay, So it's going to look the same. The difference is that we have added push notifications. There's the option to add to home screen, and this is a bit tricky to test, but we will try. We should have this add to home screen. It's not showing up here, but I'll try to demo it from my phone. So what we have done next, we have added the progressive web app features. And the progressive web app features would be offline functionality. So if from Chrome, I would go here. Network, thank you. And go offline. I just added a styling so that the user is knowledgeable that it's offline. If we refresh, we have everything still running through offline. Now, when we're setting it up offline, we're going to be looking at the cache API, and the browser cache, which is storing the image. So the image, for example, is stored by the browser cache. The app shell and the CSS is stored through the service worker and through the cache API. So let's take a look at that first. So what we have done, we have set up a service worker over here. A service worker is, like I mentioned, it's a script which runs beneath the DOM. It's at a lower level. And I recommend a tool to build your service worker instead of writing it yourself, because there's usually a lot of bootstrap code. Would be to use something like SW precache. However, here we have an example of one which we have written from scratch. The first step is to install your service worker. If the service worker is installed, what we'll do, we'll add the following files to our cache. Skip waiting is just a part of the process for service worker, and which means that it's not going to wait if there's another service worker installing. This one will take over and install itself. And by setting up this, we're storing this in the cache API. Next step would be to intercept a fetch. So over here, this event listener inside the service worker is going to intercept any network request that the browser makes. So if a user is going to make a request for a file, it's going to come in here, it's going to check if it exists inside our cache. If it does exist, send it. Otherwise, fetch it as normal. So if the user is connected to the internet, he's able to retrieve the files which are not cached also. And if we take a look at our network tab over here, you will see that a number of resources are now stored inside our service worker. And some are stored from disk cache. So the disk cache is the normal browser cache, whereas the service worker is what we have set up ourselves. And this enables us to have offline functionality, because if the user is not connected to the internet, the service worker is still running and the fetch is still happening. So the cache will persist, and we're able to retrieve these offline resources through our service worker over here. Offline manager is just what is taking care of adding that class, which is making it black and back to color in case we connect to the internet again. Yeah. So that is the first step, one of the features which you have from the service worker. The next feature is the add to home screen. The add to home screen is relatively simple, but difficult to test. So we'll look at the manifest. This is the manifest file. It's a JSON file. It's describing the project. Over here, we've got just a name, a short name, and these will be visible when you are installing the app onto the home screen as a normal app. This is what it would be named as. The icons, which will be used for this app once it is installed onto your device. The scope is the starting location. Is the root of your application, and the start URL is obviously where you're going to start. And what we do, we add this query string source equals manifest, so that for analytical purposes you're able to know that you are on that the user has loaded this from the home screen rather than through the browser. So you're able to know how many people are returning through the home screen. We have set it to display standalone, portrait mode, theme color, background color, and this is a sender ID, which is used for push notifications. So the manifest is a prerequisite to be able to have add to home screen functionality. Now, let's try so before I try to demo the add to home screen, because I'm not sure how this is going to work, we've got a small piece of logic over here, which we have set up to intercept whenever the banner comes up. So how the add to home screen works is that a little banner comes up at the bottom and it asks, do you want to add to home screen? So if we take a look back, we have it here. Yeah. So if we take a look over here, we've got this little banner over here, which will show up, and it comes add to home screen. However, you're able to intercept that, which is what we're doing over here. We're intercepting it. So we know that this is a quality application. We know that the browser trusts our application, but we don't want to show the add to home screen. But what we do instead, we store a reference to this prompt so that we can add it in the form of a button. So we will go to our settings. Just caching to clear it. Yeah. So if over here we have add to home screen. This will be enabled once the browser knows that this is a reliable app or a quality app. If the user would click on it, the pop-up that we saw before would show up and you're able to install this application. I'll just try to see if we're able to demo this through the phone. So, okay. So, this is how it would look on our phone. The same functionality we've got. Everything still works. We'll go to our settings. This thing is still disabled, but what we'll try to do, we'll try to force it to add. And this would be done through here. At the home screen, no. At the home screen, unfortunately, is a headache to test because we have no control over when the browser is going to show this pop-up. So hopefully it will show up throughout the course of the demo. But what happens if we do at the home screen? Yes, I can close. It has installed. So what I did, I installed. I did at the home screen manually from my device, and it shows up under Chrome because it's running as Chrome. However, it looks as a native app. We're able to inspect and to debug it. And if you notice, we no longer have a navigation bar over here because it is going to be loaded full screen. And there was also a splash screen, which unfortunately I cannot demo. However, it's beginning to look and feel a bit more like a native application. The next step is the push notifications. So push notifications are available on most browsers actually. And to install push notifications, you need permissions from the user. Now it's actually quite common that you get this pop-up to allow push notifications. Unfortunately, about 70% of web users block them. But this is obviously because there's probably too many push notifications on the web. So if you're on Facebook and you'll be getting pop-ups while working, it's going to be a bit tricky. So this is still something which is being fine-tuned. However, if your user has push notifications through their service worker, so over here we're checking if this browser supports push notifications and they did not deny permission for this website for push notifications, then we're going to subscribe this user using our GCM sender ID, which was in the manifest.json, which we saw earlier. And what I have done for this application, instead of it shows up by default, the annoying pop-up, if you go to the settings, let's check if this works. Settings, receive push notifications. On my phone, I've got localhost 4000 who wants to send you notifications, and I'm going to tell it allow. And what it does, it creates a registration on GCM, so Google Cloud Messaging, and it gives me a registration ID. Now, to test push notifications, the easiest way is to set up a curl. So we're going to ping a URL, we're going to send some data. I will just load the content for this curl. There you go. So this is the curl. Over here, somewhere in here, there's my key. So please close your eyes. And if we copy our registration ID from here and throw it, so we're going to tell GCM, send a push notification. In this case, there's a message which we're ignoring for this application, but send this registration ID a push notification. And we'll run it from the terminal. Success over here. And on my phone, we've got a push notification. I will do the same demo from the browser just to show what it looks like. So, yeah. So, allow notifications. Subscription failed, no active service worker. Let's refresh. Okay, so we've got our registration ID. I'll throw it into the curl once again, as it is going to be different every time we subscribe. We throw it in, and we try to send our message. Success. Wait. Copy. That's an anticlimax. So, subscribe, registration ID, copy, throw it in here. But on my phone it works. You're gonna have to trust me. But we sent a push notification, and in this case it shows the content which we have in sw.js. Excuse me. So if we go to sw.js, so over here in our service worker, we have an event listener for any pushes. We've got the text which we have for our push notification. So even if your browser is closed and your application is closed, you're still going to have the service worker running. It's going to catch this push. We're going to have this content, so time for training. So this would be, for example, every day you're going to receive a push notification, some basic content, and this would be pushed to the user. When clicking on the push notification, it's going to load the app for you. Just try one last time. Let me clear here, clear any service workers, unregister. Okay. Okay, that's a new registration ID, so let's be optimistic. Curl. Success, and still no push. I'm not sure why that's not showing up, but usually, let's do this. So Chrome settings, notifications. Let's add localhost 4000. Same registration ID. Yep. I'm not sure this is not on. It worked on the phone, but not on. But what would happen would be you see the usual push notification which shows up in the top right corner for Chrome, and it will include the messages which we have in our. When I'm connected to the projector. Okay, I didn't know that. So, how do I do that? Let's try. Oh, there we go. Thank you. You've got the push notification. You click on it, and it will take you to the website. So, thank you for that. And that covers everything. So now, if you'd be able to use this from your device, you've got an application which works offline. It works fast, and it also supports push notifications. So it is, in essence, almost like a native application. And the Chrome team have set up Lighthouse, which is a project which is used to test for performance and to check if you've got a PWA. Let's go back to our homepage and perform an audit. And this includes a number of tests. So in the case of performance, we're looking at time to first paint, which we're covering through the inline styles, which we saw earlier, and posting any render blocking CSS into the footer, and the same for the JavaScript. So we're trying to push our performance. And the progressive web app, we've got the features which we covered, including the add to home screen, which unfortunately I'm unable to demo. The only thing which we do not have is HTTPS, but that is because we are on localhost. Note that service workers only work on HTTPS apart from localhost. So if you're hosting this somewhere, push notifications and cache API are not going to be available unless you have HTTPS set up. So that covers our code demo. I'm not sure if we have any questions related to the code before I jump briefly back to the slides. No? Okay. The add to home screen, you mean? They have a criteria. It is set up by each browser, the add to home screen, and they're fine-tuning it from their end, so from the Chrome team. But for example, the previous version was that you have to return to the website twice with a 5-minute gap, and the website has to perform fast. So there's some work which is done from the developer to guarantee a good product, and there's also user behavior, which Chrome will say, hey, this guy likes to return to the app, let's offer him to add it to the home screen. So that is the criteria. So it includes both user and both development. Any other questions related to code? No? So should you build a progressive web app or a native app? Unfortunately, there is not a single correct answer. Mobile apps outpace web apps in terms of time spent on the application by 7-1. So native apps are significantly more engaging than web apps so far. However, the bigger success stories from progressive web apps, such as Flipkart, have increased engagement even on Safari, which does not have most of these features, but they managed to increase engagement through a good mobile experience through the web. So I recommend to build PWA first. So if you're building a website, the step to change it from a website to a PWA is not significant. There is not much effort to convert it from a website to a PWA. So I encourage that any website which can be converted into a PWA is done so immediately. Following that, if there would be the need to set up native apps, we see that it would be best to set up iOS native app and then Android native app because of user behavior on the different devices. So Apple users tend to install more apps than Android users, and Android then counters this by providing a better web experience through PWAs and through service workers. So as I mentioned, the source is available online. Feel free to take a look at it, to fork it, to do what you want. Ask me any questions if you have any. And that's it from my end. Thank you.
Thank you, Kevin, for your awesome presentation. And actually, we have a few minutes for questions. So if you have any for now, feel free to ask.
I will try. You were mentioned that quite recently iOS and Apple kind of starting to support at least partly. Yep. So I guess that was one of the main challenge for this kind of technology. But what is the next one, in your opinion?
Developers using it. So from the development point of view, React by default I think is now PWA. I think Angular also by default is PWA. So now the next step is to put out more PWAs available, and the learning curve is very small. It is being bundled into most frameworks and into most technologies. So once we have PWAs available, I think the transition is very short. So this was the major blocking point, and still is, because it's not available, but it seems like it's the right direction even from WebKit.
Any more questions?
Hi, I'm wondering about expiration of token for push notifications. Do you tell something more about it?
The expiration?
Yes.
Unfortunately, I don't know what is the duration. I think it is persistent, so it is managed by GCM or now Firebase, but it is, if not mistaken, it is persistent once you give allow access. The only thing which is not is the service worker, which might go, if it has been unused for a long period of time, it might be, and the browser needs more memory or more resources, because especially if you fill your cache with a lot of large resources, you will end up with a very big cache. And if the browser would need more resources, there's no limit, but if the browser needs more resources, it might terminate your service worker. So that is more the tricky part rather than the push notification token.
So user only needs to visit the page and then allow notifications, and then you can spam user for a long time, or?
Until he turns off push notifications. So in the demo, we had the off option as well. So
okay, thank you.
You can turn them off.
So, any last questions? So, okay, that's all for now. Thank you for attending. Thanks, Kevin. Thanks, Bartek. And see you next time on next meetup.
Thank you.